In this lecture presented by www.free-academy.com, we're going to start our practice with exponential growth and decay. We've been given the function q of t equals q naught e to the negative 0.003 t, and this is the function that describes the substance remaining after t years of a given isotope, a radioactive isotope, and we want to find the half-life. What is the half-life? The half-life is where we have the amount of time that it takes for half the substance to decay. So if we start out with, say, an X amount of subject, after one half-life, we have 1/2 the substance left. And after another half-life, we'd have 1/4, and then 1/8, and so on and so forth. This is a pretty useful quantity to know. It comes up quite a lot in physics. It's used in medicine too. The half-life of a particular isotope is used if you're like getting a contrast MRI or something of that nature. You want something that decays really quickly so it doesn't stay in your system very long. It's also used for carbon dating. Knowing the ratio of a certain isotope of carbon to another isotope of carbon allows us to determine how old something is based on the decay rate of the different isotopes. So half-lives are a good thing to know. But basically, we're trying to find q of t such that it's equal to q naught over 2. If t was equal to 0, we'd have e to the 0, which is equal to 1. So q of 0 equals q naught times 1, which is q naught. So we're trying to find q of t, which we'll do 1/2 for a half-life, and that will be equal to q naught over 2. To actually solve this problem, let's do something interesting. Let's divide our sides by q naught, so we'll get qt divided by q naught is equal to e to the negative 0.003 t. Now, finding something when it's in an exponential is quite the pain. Fortunately, we have the trick to this. We can take the logarithm of both sides. And because this is exponential, we'll take the natural logarithm, so it has the appropriate base. So we'll have ln of q of t divided by q naught is equal to negative 0.003 t. That's all fine and dandy, but where do we go from there? Well, we're going to use this formula. We're going to use the formula for the half-life. We're going to find q of t such that it's equal to q naught over 2. So we can plug that into our equation to get the natural log of q naught divided by 2, all divided by q naught, is equal to negative 0.003 t. Well, the q naughts clearly cancel, and we have 1/2 divided by 1, so we're going to take the natural logarithm of 1/2 is equal to negative 0.003 t, and then we can solve for t. ln of 0.5 divided by negative 0.003. Now all we need to do is plug that into our calculator, and we're going to get 231 years. So after 231 years, this isotope will be half of its original value. There wasn't anything complicated or special here, just as long as you remember the trick for your half-life, you replace it with q naught over 2. So there you go, that's this problem.